In this video, I will show you how to calculate kinetic energy. As you likely know from watching the kinetic energy video on this channel, kinetic energy is directly related to both mass and speed. Physicists have put together a formula to calculate kinetic energy using mass and speed. Let's first dissect the formula and then do some practice problems. The formula used to calculate kinetic energy can be seen here. For every problem dealing with moving objects and kinetic energy, we will use this formula. On the left hand of the equation, Ke stands for kinetic energy and is measured in joules and abbreviated with a capital J. On the right side of the equation, we first have m, which stands for mass, and must always use the unit kilogram, abbreviated as kg for the formula to work. Finally, second is v, which stands for speed, which is measured in meters per second and abbreviated as m/s. In order to solve this equation, you have to plug in 2 out of the 3 missing values. The tricky part is picking apart the problem and identifying what information is given, as well as the unknowns. So let's do a practice problem. This problem says, determine the kinetic energy of a 625 kilogram roller coaster car that is moving with the speed of 18.3 meters per second. So I see the words moving and kinetic, letting me know that I need to use the kinetic energy formula, which is Ke equals 1/2 mv squared. So looking at the problem, we notice that it's asking us for Ke. We know that it has to be the variable, it is the unknown, which means that we already know we have 1/2, and now we just need to find mass and speed. So we see the mass here, 625 kilograms. Kg is the clue there that that's the mass. So let's put in 625 for m. Now for the speed, it literally says speed right there, or the other clue is meters per second, the unit. So let's put in 18.3 in place of v, so have the squared. Now order of operations says do the squared first, so we'll do 18.3 squared, which is 334.89. So we're going to take 334.89, multiply it by 625 and 1/2, and we'll set all of that equal to Ke. So when you multiply everything, you get 1088.39 joules equals kinetic energy. Alright, so let's read our next problem. This problem says, Missy Dyewater, the former platform diver for the Ringling Brothers Circus, had energy of 1200 joules just prior to hitting the bucket of water. If Missy's mass is 40 kilograms, then what is her falling speed? So I'm seeing falling, so I know this woman is moving, meaning it must be kinetic energy. So I'm going to write down my Ke equals 1/2 mv squared formula for kinetic energy. So I'm seeing that it's asking for her speed, and I know that stands for v. So let's put in v squared as our variable, since that's clearly our unknown. Now we need to find the mass, and I see kg, so I know that 40 kg gets in place of m. And we'll put the 1/2 there where it belongs in the formula. So let's go ahead and simplify this side as much as we can. 1/2 times 40 gives us 20v squared. And we'll set that equal to the value for Ke, which is 1200. You notice this because it has the J for joules. So it must be Ke. So now we have 1200 equals 20v squared. So we'll divide both sides by 20 to continue to isolate the variable. That gives us 600 on the left side of the equal sign, and if the 20s cancel out, it'll give us v squared on the right side. So now to simplify an exponent, we need to do the square root of both sides. And the square root of 600 would be 24.5 meters per second equals v. And that's our answer for speed. So let's do one more problem. A quarterback throws a football that has 245 joules of energy as it moves. The ball is moving at 35 meters per second. What is the mass of this ball? So right away I'm noticing that the ball is moving. That's my clue that we have to use the kinetic energy formula, which is Ke equals 1/2 mv squared. So the next thing I'm noticing is that it's saying what is the mass of the ball, meaning that mass is going to be our unknown. So let's fill in m for our unknown variable. That means we have to find Ke and v. So looking up at the top, I see 245 joules. If I see joules, I know it's Ke. Let's plug it in 245. We'll keep the 1/2. And now I look at 35 and I see m/s, so I know that's our speed. So we'll put in 35 squared. So order of operations, we'll do 35 squared first, which is 1225. Put in our m and 1/2. And now multiply the 1/2 by 1225 to give us 612.5 m equals 245. So to simplify further, let's divide both sides by 612.5 to isolate our variable. So the 612.5s cancel out, giving us m by itself, and 245 divided by 612.5 equals 0.4 kilograms, which is our mass.